All right, so we're going to start the review for the AP exam by looking at differential equations. You can skip the first section that's parametric and polar equations because they took that off of the exam. So we're going to start on page 17. This was a differential equation problem from back in 2015. And we'll go through and you'll see the different types of problems. This is a pretty common problem that's on there. And it's also on the AB exam. So I would suspect you only have 2 questions. I would suspect that this may be one of the 2 types of questions that you see for your open-ended. All right, so let's see what they have to do. So for part A, they said, here's our differential equation. And we're going to go through and sketch the slope field just using the 6 points that they give us here. So I would suggest that, you don't have to write this out. They're just looking at this. But I would probably write the t-chart there for the coordinates for x and y. So my first point's at 0, 1. I have a point at 0, 2, a point at 1, 1, a point at 1, 2, and then 0, negative 1, and 1, negative 1. I'm going to plug those points right into that differential equation there and simplify. So 0 minus 1 will give me negative 1. 0 minus 2 is negative 2. 2 times 1 will be 2, minus 1 will be 1. 2 times 1 will be 2, minus 2 would give me 0. And then 0 minus negative 1 would be 1. And then 2 minus negative 1 would be 3. So those are our 6 points, and then just go through and sketch those slopes. So at 0, 1, I have a slope of negative 1. Remember, you're just estimating, try to make the segments the same length. 0, 2 is going to have a slope of negative 2, so slightly steeper. 0, negative 1, here's that one, has a slope of positive 1. What else do we have? 1, 1 has a slope of positive 1, so I'm going to kind of make it look like that one. And then 1, 2 has a slope of 0. And then 1, negative 1 has a slope of 3, so something steeper. So that's what they're looking at there. Nothing spectacular with that slope field. For part B, they ask us to go through and find the second derivative. And then they want us to determine what kind of concavity all those solution curves would have. So let's put this on a separate piece of paper here. So for part B, my derivative they gave me was 2x minus y, right from the first part. So let's find the second derivative. So second derivative is going to be 2 minus, well, the derivative of y with respect to x is going to be 1 dy over dx. And then I could rewrite that as dy over dx. I know that's equal to 2x minus y, or 2 minus 2x plus y. All right, so there's my second derivative. And then the other piece of it is what happens in quadrant 2. So I would think about what happens in terms of our x and y coordinates. So my x coordinate is going to be negative. My y coordinate is positive in the second quadrant. Think about what that looks like. So my derivative then is going to look like, second derivative is going to look like 2 minus 2 times a negative number plus a positive number. So that's going to be 2 plus minus a negative is going to be plus a positive number plus another positive number. Well, positive plus positive plus positive is going to be greater than 0. So since my second derivative is greater than 0, all of the solution curves in quadrant 2 will be concave up. So that's part B. Pretty straightforward. Part C, they said, let's look at this point, f of 2 equals 3. I'll set this up in 1 second. And they said, let's find if f has a relative max, a relative min, or neither at x equals 2. All right, so let's think about what that looks like then. So my derivative was 2x minus y, and they said specifically at this point 2 comma 3. Well, to have a max, a min, or, well, neither, to have a max or a min, dy over dx would have to equal 0. So for the original function to have a max or min, the derivative has to equal 0. So let's see what we get when we evaluate this derivative at the point 2 comma 3. So I'd have 2 times my x-coordinate is 2, minus 3 gives me 4 minus 3, which is 1. It's greater than 0, it's not equal to 0. So since dy over dx does not equal 0 at that point 2 comma 3, the x-coordinate 2 is neither a relative maximum nor a relative minimum. All right, so that's the second part, or the third part. And then the very last part, this one's kind of a tricky question here. So they said, find the values for the constant m and b, where y equals mx plus b is a solution to the differential equation. So they're really saying, where is this, what are the values for m and for b that makes that the tangent line to that curve there? So we have to come up with those values there. So, you know, one thing that you can do with that is you can kind of think to yourself, well, the derivative would have to equal the derivative of this thing here. Right, so the derivative of y would be dy over dx, derivative of this side would just be, I wrote it in just the derivative form. So if I take that dy over d, or d dx derivative and sort of distribute it to each of those terms there, I'm going to have the derivative. Well, derivative of mx, think about m, that's my coefficient's just some constant term. So the derivative of like 3x would be 3, so the derivative of mx is just m. And then if I take the derivative of b, b is a constant term, its derivative is going to be 0. So my derivative just equals m, which is the slope for the tangent line, which you would think would be the derivative. So I can take out this dy over dx, replace it with the 2x minus y from the original problem, right? And set those equal to each other. Now I can do another substitution here. Remember, we know what y is equal to. Y is equal to mx plus b, so I can take this y out and plug that in. So I'll have 2x minus mx plus b equals m. And I can rearrange this, distribute that negative. I'm going to move this m to the left-hand side as well, set it equal to 0. Now you can do some factor by grouping. If I group these two together, I can factor the x out. If I group these two together, I can factor the negative out if I want to. And then think of this step here. This is what I thought was kind of tricky with this problem here. Think of this, how we separated partial fractions. How we separated that. And the reason why I say that is because you have to come up with the equation to solve for it. You have all these variables here. So if you think about my coefficient for x is this 2 minus m. Whatever number this is going to be the coefficient for x. On this side, I don't have any x's. So my 2 minus m that coefficient has to add up to the coefficients for x on this side, which I don't have any x's, so it has to equal 0. Then my second equation is going to be my constant term. So this is my constant term, negative b plus m, and that has to equal my constant on this side, which is 0. And this I can solve. I get m is 2. This, if you plug in 2 for your m, and I distribute the negative all at the same time there. Maybe that wasn't a good thing to do. I'll get b as negative 2. So that last piece was pretty tricky. But let me show you how they divided up the points for this problem, because that's each open-ended question is worth 9 points, assuming that they're grading everything in the same fashion that they have in the past, which I would assume they would. The first problem here, this one's 2 points, and usually they'll divide this up, like maybe for this one they would say all of the slopes on x equals 0 would be 1 point, all of the slopes graphed correctly on x equals 1. Sometimes they would do 0 slopes, like if you had maybe half of these were 0 slopes, they would give you 1 point for the zeros and 1 point for the non-zero slopes. So they kind of divide it up like that. For the second part, so the first part was worth 2 points. Part B is also worth 2 points. They gave us, let me see, they gave us 1 point for coming up with this derivative, second derivative, and then they gave 1 point for determining the concavity there. So all of this explanation there. And then part C was also worth 2 points. Part C was worth 2 points. You got 1 point for sort of, either one of these things here, saying that the derivative wasn't equal to 0 or the derivative was equal to 1 at x equals 2, and that it's neither a max or a min. So this one was also worth 2 points. So that's 6 points total. And then finally letter D was worth 3 points. They gave us 1 point for sort of this setup here, taking the derivative and setting the derivative of the solution equal to the other derivative there. They gave us 1 point for substituting back in there and saying the derivative, 2x minus y, is equal to your m. And then they gave 1 point for coming up with those coefficients there, so 3 points total. All right, so now you're going to go back through and you're going to do problem number page 16, the one before this, and then also 18 and 19 are 2 other differential equation problems. So 3 differential equation problems, and then the solutions will be posted online for you. You can check your solutions. I want you to upload them so that I can see that you're doing the work there. I'm not going to grade them for correctness. Go through and see what you can do with